All right, so we're going to today solve systems of equations that have three variables. And so a third dimension is added. So before we had a line or a parabola and you were looking for a point where the line crossed the line or a line crossed the parabola or whatever. But when there's three dimensions or an x, y, and a z, three variables, you have planes. And so sometimes they don't all cross at the same points or at the same place. So out of these five, pick out three where you think don't have a solution. They don't cross at the same place. The first one, definitely. Bottom left definitely has no solution. Yes, so those are the three. These three right here. When there's no solution, they're called inconsistent systems. They cross each other, but they never all three cross at the same place. So sometimes they're parallel planes and they don't cross at all. Inconsistent, yes. And sometimes some of them cross and some of them don't. Okay, so that's the inconsistent system. Sometimes there is an independent system where they all cross at one point. So out of those left, which one does that look like it is?
The top middle one.
This is the one where they all cross at one point.
Doesn't the other one too?
They all cross, but not at a point.
The middle.
They all cross at a line. So this one right here, they would all three cross at one point. That's an independent system. There's one solution. Right? And then this last one, they do all cross, and they all cross at the same place. But that place is not just a point. That place is a line. So that's going to be infinitely many solutions.
So they have many points of contact?
Yes, many points of infinitely many points of contact. That's a dependent system. And there's infinitely many solutions. Now, we're not going to have to draw these. You're not going to have to really worry about that. We're just going to solve them. And for the most part, your calculator does all the math for you. Whenever we have a dependent system, there's a little tiny bit that you are going to have to do on your own, that the calculator doesn't just tell you what to do. But most of this is knowing how to put it into the calculator. And it is something you did in Algebra 2. Most of what we're learning is. Okay, so we're going to use the matrix features and RREF of the graphing calculators to solve systems of equations with three variables. And you do need to know, like, if your calculator gives you this is what it means. And so if it's an independent system, like this blue one right here, I'll show you, we're going to write down a possibility for answer in your calculator. So it would be RREF of matrix A equals, and then we're going to do a matrix that has 3 rows and 4 columns. So the first row, we're going to do 1, 0, 0, 2. The second row is 0, 1, 0, negative 5. The third row is 0, 0, 1, 4. All right. And so this is what we want to see. We want there to be a diagonal of ones. And then in the first 3 rows, the other numbers that aren't a diagonal of ones are all zeros. And then your solutions come from this row. And so your solution is what's called an ordered triple. So you learned about ordered pairs a long time ago. It was X and a Y. Ordered triple is X, Y, Z. So the solution to this system would be 2, negative 5, 4. That's your X, your Y, and your Z. Right, that's what's going to happen when there's one solution when it's an independent system. The dependent and inconsistent systems, that last row is going to be wonky. Actually, all the rows are going to be a little bit wonky. So for dependent, you'll get RREF of A is equal to a matrix that's 3 by 4. Nate, you'll understand better if you pay attention. All right, that first row will be something like 1, 0, 3, 2. So that row, you can kind of tell something's messed up, where this number right here is supposed to be a 0. It's an actual different number of 3. All right, the second row would be 0, 1, 4, 5. And the last row is 0, 0, 0, 0. So this is like whenever we were doing this by hand and you would get something like 0 equals 0. That's the same situation. And that means there's infinitely many solutions. And we are going to represent these solutions today with kind of like expressions. So we will represent these. We aren't just going to say infinitely many solutions and be done. We're going to talk about what those could be. All right, and then the last kind, the inconsistent system, is like the green section. So this one, we'll get RREF of A equals. All right, and so our first two rows are going to be similar to what we just got in the purple one. So I'm going to do 1, 0, 4, 5, and I just made these up this morning. And 0, 1, 3, 2. And then this last row is 0, 0, 0, 1. So this is like what you would get if you were solving and you got something like 0 equals 5 or 0 equals 1. That is not true. And when that happens, there's going to be no solution and you're done.
Would you have to find this if you already do it with no solution?
No. Like you would just do all the work, you get that, and you're done. You say no solution and you're done. And like I said, the calculator is going to do most of this for you. So let's look at number 1. Over on this side, I have some notes of like what you type in the calculator, what it looks like. These are not as detailed as the notes that I give in Algebra 2 because you've done this before and you guys are super smart. You don't need all the little step-by-steps, I don't think. All right, so the first thing we want to do is put this matrix into the calculator. So let me get my calculator pulled up. Okay, and so right here, it tells you you're going to hit second, you're going to hit x to the negative 1, and then you're going to hit the right arrow twice. And it's going to look like that screen that's right below that. So second, x to the negative 1, go over to edit. Now, it's possible that you don't have this 3 by 4 right now, especially if your calculator had been reset. It's fine. We'll fix it in a second. So just hit enter on edit. All right. You may or may not have some numbers in there, depending on the last thing that got typed in. It may be all zeros, but we want to have 3 by 4. So if beside matrix A, make sure it's 3 by 4. Enter, yeah. All right, and then the matrix that we're going to put in is going to be the coefficients and what's after the equal sign of this matrix. So the first row is all about this first equation. And so if there's not a number in front of the x, what is there? 1. So it's going to be 1, negative 2, 3, 9. All right, so this next equation for the x, it lines up under the other x, so it's negative 1, 3. And then what do you think we do about the z? 0. There's not a z, but 0, and then negative 4. And then the last row is 2, negative 5, 5, 17. That's what we're going to put in for matrix A. So as you put these numbers in, make sure you hit enter after each one. So just type over what's already there. There's no reason to clear it. So just hit enter after each one. Now, as simple as that seems, it is super easy to mess that up. I've messed that up so many times. Part of it is because the battery in my mouse is dying, but it just be careful, take your time. We're not going to do like 100 of these, so don't worry. All right, so once you get all that typed in, you are at this part right here. And so now we need to quit out of the matrix menu and just go back to the regular home screen. And so that's just second mode to quit. Bless you. All right. Now we should be at the second row. So what we're going to do is we're going to go back to the matrix menu and we're going to go over to math. And what we want to choose is B, that's RREF. So it's second, x negative 1, right, and then up 5 times. But what we want is RREF. Right? So you tell it. RREF stands for Reduced Row Echelon Form. Now, I don't know if any of you guys are going to go very far into math classes when you're in college. If you take a class called linear algebra, it's all about matrices. You'll learn what your calculator is doing right now to turn it into reduced row echelon form. We're just going to let the calculator do it. So now we need to go back one more time and choose matrix A. So it's second, x to the negative 1, and just enter. And then just hit enter one more time. See, I messed it up. It's super easy to mess it up. You guys shouldn't get all these ugly decimals. Why did you wait to tell me?
I got 47.
There we go. This is what you should get. This looks beautiful. So we have this diagonal ones. We have all those zeros. And then those are going to be your answers. And so it's X, Y, and Z. And I would just give them as an order triple. An order triple. X, Y, Z as an order triple. Now, on multiple choice questions, a lot of times they don't ask for all three because they know you can plug those answer choices in, and they'll just ask, like, what is the Y for this system? And you would just choose the negative 1, or what is the X? So just make sure you follow the directions. You guys want to try one on your own? Yeah, you guys try example 2 on your own, please. I'll leave the steps up so you don't have to flip back and forth.
Do the same 3 times 4.
Yes. All of these that we're doing with the 3 equations with 3 variables is going to be 3 times 4. All right, and just a hint, you don't get any weird decimals or fractions on this. It's just regular old integers. If you got something, like when I knew I did it wrong when I got those ugly decimals, then see if you can find your mistake, like Wayne found my mistake.
What are you supposed to get?
Did you get all integers?
I got -2, -3.
That's what I got.
No, I did. I broke it somehow.
It's crazy.
This is what your matrix A should be.
We're classifying as independent, dependent, or
We are. So if you get one answer, what is it? What type?
is independent.
Independent. Good. All right. Any questions? Did y'all all get this?
Yeah.
If you didn't, it's probably you typed something in wrong, and I can try and help you if you can't find it yourself. All right. So on the next one, I'm going to write down the matrix we're going to make matrix A.
I can do this, guys.
We can just do it. We can do the second one.
Yeah, this one has a little bit of a catch to it. No, some people are feeling good. You're going to keep feeling good, but this one's going to have a little bit more work. All right, so remember it's second x to -1 over to edit, and then we put in these values. All right, I think I'm okay this time. So don't forget to quit out of here. Now that RREF-A is already in our calculator, we can just hit enter. I want you should practice it several times, but it's there. All right, and so I can tell this one's gonna have an issue where it's supposed to be a 0. It's 1/3 basically. Where it's supposed to be a 0 here, it's 2/3. I want to see everything at one time. So anytime you want fractions instead of decimals, if you just hit math and enter, and then enter again, it changes it to fractions instead of decimals. And you can see the whole matrix. All right, what do you guys notice about the last row? It's all zeros. So I'm going to jot this down.
Just that one you talked about, right?
Yes.
That inconsistent.
This is
This is dependent.
dependent, right? To turn it to fractions, you just hit math and then enter twice.
Does this no longer have solutions?
This one is going to have infinitely many solutions that we are going to represent. So we're not done. This is the type that there's more work to do. Okay, so anytime you notice that is a full row of zeros, then it's dependent, and just know that we're going to have some more work to do. We can do it. It's just not going to be easy as the last two. All right, so this one right here is what tells you about z. So we're going to say that z is just z. All right, and now we're going to work backwards. So we have been doing equation to matrix. Now we're going to go from matrix to equation. And so this row right here, this is the x, right? 0x. And then what should the y be? 1y plus 2/3 z equals 4. Now we don't want all that stuff. We just want to know how we can represent y. So what would you do with that 2/3 z? Subtract it. So that's what we're going to use for y. Z, we're going to just say it's z. Y is going to be 4 minus 2/3 z. You guys figure out what x is going to be. It's going to be very similar to y, but different. Use that first equation. Put in your x and your z. So this one gave us this. So there's no x, there's 1 y, there's 2/3 z, and equals 4. So it's like we're doing backwards from what we went from here to here. It's like we're going from there to there.
It's just like transformed into y equals, right? The y equals mx equals b format.
Maybe. Now we can't do that with z because z doesn't have anything. It's just all zeros. So now I can take this first equation and make it 1x, no y, plus 1/3 z equals 3. So what does x equal?
3 months.
Yes. All right. And then I can still write this as an ordered triple.
Oh, they're just like the full equation.
And that represents all the solutions. So like you could say z was 6. If z was 6, let's do 3. Let's say z is 3. If z is 3, then x is 2 and y is 2. So you can just take that number, put it in for z, and it gives you a solution. There's infinitely many solutions because there's infinitely many things z can be. Sorry, I'm getting a little messy. There's infinitely many solutions, but you just represent them that way. All right, why don't you guys try this last one on your own?
It's just like 3.
Nope. It's actually going to be a little easier than 3.
There isn't one. Say no, go back to lunch.
Oh, I pulled up the last one.
This would be 3/4 at the bottom. So that's negative 3/4 plus 75.
There we go. I don't know why I pulled up.
What are y'all looking at? What are you doing?
All right, so this one, you get 0, 0, 0, 1. So what does that mean?
Independent.
Not independent.
It
It means no
Where did I
solution.
get 22 from? That's what it gave us. That's the value it gave me. I did look at it right.
And no solution means inconsistent. If you didn't get what I got, I didn't get it the first time. I don't know what my calculator did.
You got 1, -4, 2, -8. I got 2, -6, -14, 7.
It's positive
It should be
14.
positive 14.
See, Tyler is grandpa.
There's lots and lots of ways to mess up.